public key encryption system. Based on a mathematical idea, is that if you have two keys or two numbers that can be applied into a formula to encrypt or decrypt or to change a value and bring it back in such a way that it can still remain secure and safe. And they found this idea, this formula, that it would require two numbers. And once those two numbers are generated, if you see one of them, you can never work out, you can't easily work out what the other number is. But if you take data or some number and apply this, one of those keys, we call those keys, they can easily be generated, again mathematically. But if you apply one of the keys in a formula, it will change whatever the data is. And it cannot bring it back. The same key cannot bring it back. You need a second key, this other number that we generated with this, that if you apply to the same formula, but to the new cipher message, it can bring it back. So now we have two keys. One will do encryption and the other one will do decryption. We're not using the same key. This is the basic idea of public key encryption system. It's just like having a lock or a door or a safe, that you can take one key, unlock it, and you cannot unlock it with the same key. You have to bring the other key to open it. So one will lock, the other one will open. And these two keys will do each other's work. So if this key, it does the locking, it cannot unlock, only this key can unlock it. So the idea is simple. Two numbers, one of them will do the encryption, the other one will do the decryption, or vice versa. Maybe the first one can encrypt and the second one can decrypt, as long as you have those keys. Now the idea, those two keys are easily generated. So we'll find out later on how to generate them and how to do the actual encryption algorithm. So you generate a pair of keys. In 1 second you can generate a pair of keys that are related, strongly related together, but we cannot see the relationships between them. It's very difficult. If one of them is missing, you cannot work out from this key what the missing key is. And that's an important point. So one important characteristic of those two keys is that if you see one key, you can never work out what the other key is. Either one of them. And the other main characteristic is if we apply this one to encrypt or lock, only the other one. There's no other key in the world except the other one that was created with it. I call them twin keys. So those twins, one of them will lock and the other one unlocks, or vice versa. So this is the characteristics of those two numbers. See in one of them, you can never tell what the other, or work out or calculate what the other number is. And the other point, either one of them will do the locking, the other one will unlock. Now, once they worked this out, they said, okay, now to implement it, this is the way it will work. Create a pair of keys, and if you don't like them, you can create another pair. There are millions and billions of keys, of numbers, that can easily be created. So you can create a pair. Let's say you created those two pairs, this pair of keys. Now, they say, keep one of them to yourself. So I'm going to keep the red one. Nobody will see this except me. And we call that's my private key, and this is my public key. And this is where the name public key encryption came from. So everybody can generate a pair of keys and can tell us what their public key is, and they hide their private key. So this key is no longer a secret key. Now, if you want to send me a message nobody in the world can read except I, then you can look up my public key and it's not secret. If you want, I can send it to you. We have public key directories, like telephone directories. You can put my name and you get the public key. My public key is just like a phone number. Or there are many ways. We'll look later on how we can actually distribute those keys, but they are not secretive keys. That's the good thing about them. They are easier, a little bit easier to distribute than the other keys, the secretive key, that in the conventional encryption system. Now, I can have it on my email. Every time I send the email to somebody, I say, here's my public key. It's always there, my signature maybe, or on my website, or in my documents, it doesn't matter. It's always available. So you can get this key and use it to lock that message, encrypt that message you want to send me. Who can read that message? There's no other key in the world that can unlock it or decrypt it except this key that I have, that no one else in the world has. So everybody can get a copy of that encrypted message. They'll never be able to read it. When I get it, I can read it. And this is the simple idea of public key encryption system. And that's how the message can be confidential. That means nobody can read it except me, who have that private key, provided you use my public key. Okay, so that the idea is so simple. If you want to send a message to anybody, we all have a pair of keys. Every one of us has a pair of keys, at least. You can have more than one pair of keys. Many companies and many individuals can have many, and you use one of them to communicate with somebody and use another one to communicate with someone else. It's just like phone numbers. You can have multiple phone numbers as well. But anyway, so if you want to send a confidential message to somebody, which key would you use? Now, this is the problem. Your options are 4 keys. You have a pair of keys and I have a pair of keys. Which key would you use to encrypt? Which key should be used for encrypting the message? And which key should be used for decrypting the message? That's something you need to know. And it's simple. And yet, a lot of students have a lot of problems with it. So just get the logic of it correct and you should have no problem. And the simple logic is 2 points you need to know. If you want to send a message to somebody, if it's confidential, use the receiver's public key. Of course, I'll say use the receiver's key. Which key would you use? My public key or my private key? Just remember, logically, you don't have access to my private key. Nobody can see my private key, so it's easy. You can only use the receiver's public key. So if I ask you which key would you use to encrypt the message, don't tell me the receiver's private key. You don't have access to that. You only access the receiver's public key. Now that's how simple it is. So all you need, for example, if you want to send a message to Mr. X, all you need is Mr. X's public key, not private key. If you have it, then you can encrypt the message and send it. Everybody can get a copy of that encrypted message. They cannot read it. The only person who can read it is the person who has that private key. So it's your responsibility to keep your private key to yourself. Never give it to anyone. Not to your friend, not to your husband or wife, not to your partner, not to your boyfriend. Nobody should have, not your parents. That key should be kept just by you. So that's the simple idea. Now, as well as this, I'm going to ask you a question. If I take a message and I encrypt it using my public key, a message, a file, document, and I encrypt it using my public key, who can read that message? Only I, because I am the only one who has the private key that can decrypt it. That's how a lot of companies make their files secure. So if you want to make your files secure on your laptop, that's all you have to do. Generate a pair of keys, they're both your keys, encrypt all the sensitive messages or files or data on your computer, encrypt it with your public key, so even if you lose your computer, nobody can read that information. It's all encrypted. And whenever you want to read it, you produce your private key, decrypt that file, read it, work on it, edit it, do whatever you like. Before you leave it, encrypt it again with your public key. And this is actually a legal requirement. If you work for any organization or any company in Europe or America or Canada, and you have data on that computer, on that laptop, you're not allowed just to have it in its pure format. You must encrypt it. So even if you lose the laptop or the computer, other people find it, they cannot read that information. All right, so that's one thing. If you want to make information confidential for you, confidential and secure, or in your organization, you can write an application that says, okay, where's our sensitive files? They're in this directory. Encrypt everything. You don't even give the staff the key. And then staff member, once they identify themselves, you can decrypt the file and give it to them. When they send it back for storage, encrypt it and put it back. So that can be a project you can have to keep information secure in an organization, or on a laptop, or on a PC, or something like that. Now, the other thing, what if I take a message and I encrypt it with my private key? And I send the message out. Who can read that message? Whoever has my public key. And because my public key is public, then anybody can read it, as long as they get my public key. My public key is available, and we assume they all have it. So if you encrypt a message, if anybody encrypts a message with their private key, and they send it out, that message is no longer confidential. Because anybody in the world can read it, because all they need is your public key, and your public key is public, and everybody has it. But what's so great about this, I know it's not confidential, but if I can take a message and take your public key and decrypt the message, and I can successfully decrypt it, that means that's a proof that your private key was used. If I can use your public key to decrypt it, then your private key was used. And that's the idea of digital signature. So a digital signature, if you can decrypt a message using somebody's private key, that's a full proof that they have encrypted that message. And that's where the non-repudiation comes. Anybody remembers what non-repudiation is? You cannot deny that you have encrypted a message or sent a message. If you encrypt, is that what you said? Yeah. So if you cannot deny that you've encrypted a message, now we can prove in a court of law that yes, this person encrypted this message. And the judge won't know, but he'll call an expert and say, how do you know? He says, because we can decrypt the message using his or her private key. That means, we can decrypt it using her public key. That means it was encrypted using the private key, and nobody else in the world has that except this person. Well, that's the proof. All right. So the next point, the hint to remember, it doesn't matter who encrypted or where. If I'll be asking you later, this message was encrypted by Alex or Alan. And Bob, which key should Bob use to decrypt it? It's the same person. If one person's key, whether public or private, if you use one of my keys to encrypt, if one of my keys was used to encrypt, then the other key of mine, only my other key would decrypt. Keep that in mind. So whoever encrypted the message, if I ask you, which key should we use to decrypt it? Just find out who encrypted it, whose key was encrypted by. By X, Mr. X. Whether it's the private key or the public key, we'll use the other key of Mr. X. So the same person, if one of their keys is used to encrypt, only the other key can be used to decrypt. Don't say, oh, will the receiver then, or the sender. Don't get yourself mixed up. If we use the receiver's key, then the other key of the receiver. If we use the sender's key, then it's the other key of the sender. So the same person who encrypts, also the same person who decrypts. Well, not the same person, but the key that belongs to that person. Right? Just remember that and things will look much easier. But just to check that this is correct, All right, who's gonna help me here? You okay? We're gonna send a message to her that nobody can read but her. That's confidential message. Which key would you use to encrypt? Which key would she use to decrypt? Use the receiver's public key to encrypt. Anytime I send a confidential message to someone, use that someone's key, public key. Of course, I don't just say use the public key. There are two public keys. You have two keys, the receiver has two keys, you need to tell me the receiver's public or private key, or the sender's public or private key to encrypt. Right, so you use her public key to encrypt the message, and not what she used to decrypt it. And she'll use her private key. So, can you, right? You want to send him a message, a confidential message. Which keys should you use to encrypt, and which key he should use to decrypt? Yeah? Okay. Okay, so simple, great. Piece of cake, right? Now let's go to the other way. Instead of confidential, now we want an authentic message. A message that we know only that person. It's not necessarily confidential, everybody can read it, but once they read it, they know he actually encrypted that message. So I'm going to start with you. I'm going to send him over there an authentic message that if he reads it, he knows it came from you. Okay, it sounds simple. Does everybody know that? Okay, you want to send me a message, I know it came from you. You encrypt it with your private key. Then you send me the private key then. Okay, what about the message? You send the ciphered message. That's encrypted by your private key. How would I read it? So you use your private key and I use my public key to decrypt it. I said, whenever a message is encrypted and decrypted, make sure it's decrypted by the same person's key. You can't encrypt with your key and I decrypt with my key. It have to be either both of them your keys or both of them my keys. All right? Do you understand? Right. So you want to send me a not a confidential, authentic message. I know it came from you. How would you encrypt it? Use the private key, right? Guys, if you tell me use the private key or the public key, it's error. You must say the sender or the receiver's private key. Don't just say private key. In an exam, you say private key, you get 0. You need to say the receiver's public key or private key or the sender's private key. Don't forget the word sender or receiver. So if you want to send me a message, I know you wrote it for certain. You encrypted it. How would you encrypt it? So you encrypt a message with your public key. How would I read it? With your private key? I don't have access to your private key. Listen to the answer. Here it is. Yeah? You want to send me an authentic message? I know it came from you. That's correct. Thank you. Guys, make sure you get this. If you get this, the rest of it is so easy. If you don't get it, it will take a long time before you clear it up. All right, so this is the basic idea for public key encryption system, for digital signature, as we will do it later, and for many other bits and pieces that will depend on this simple idea. So it can be used for confidentiality or authenticity. And you could be asked, explain how it can be used. How is public key encryption system used for confidentiality? And this is the system. These are the main components. The plain text message, right here. And the key. And this is the encryption algorithm. But it's important to know which key. So this here, Bob wants to send a message to Alice. So which key should Bob use to send a confidential message? He should use Alice's public key. Don't ever say Alice's private key, because Alice's private key is private to herself. No one else can use it. So Bob, usually, which could be you have a list of all your friends, like phone numbers, but this is public keys. So everybody in the new system will have many public keys that belong to the people they communicate with. So you'll pick, Bob will pick Alice's public key, use it to encrypt this message through this algorithm and send it out as a ciphered message. The ciphered message is received by Alice, and she can use her private key to decrypt the message. As you notice, her public key was used, Alice's public key to use to encrypt, and now Alice's private key is used to decrypt. Same person. Or think of this. Don't get yourself mixed up. If you encrypt the message with Alice's key, you can only use Alice's key to other key to decrypt it. And she can generate that key, that message. And if you want to send an authentic message, then this is the way to explain it. You take the plain text message and the algorithm, and you use the sender. This is Bob. Bob uses his private key. And once the message is encrypted, then Bob's other key needs to be used. So when Alice receives the message, she must use Bob's key, Bob's public key. And don't just say Bob's key, you must say which of his keys, the private or the public. So in an exam, if you explain it, but you don't say, here you say, Bob uses his key to encrypt the message. That's zero, that's no good. And the receiver, if you say, Alice uses Bob's key, then it's no good. You need to say Bob's public key. Now, sometimes, so remember, you either send a message that's confidential, nobody can read, or a message that can only be, you know who sent it, but it's not confidential. Because sometimes you don't want to, like there's so many documents that are sent from one place to another, they're not necessarily confidential, but you want to make sure it came from that right person. It's like if I send you an email and I say, don't worry, don't upload the solution to that assignment or that tutorial, you don't need to. I'm giving you the 10 marks for free. I'm signed Faheem, but it's actually, I didn't send it, someone else sent it to you. So you need to authenticate that. So sometimes you need a message to be both. You want to send it confidential, but if you receive a confidential message, you are never sure who sent it. Because anybody can take your public key, encrypt the message, send it to you, and sign it with any name. So yes, it's confidential. Nobody was able to read it except you, since the sender sent it. But you're not really certain who the sender is, because everybody has your public key, and everybody can take your public key and use it to encrypt a message and send it to you. And they put a different name underneath it. So it's not authentic. When you receive a confidential message, it doesn't mean you're certain of the sender. Now, on the other hand, if you receive a confidential message, if somebody used your, if you want to use an authentic message, the person has to use their private key, send it to you, and you can decrypt it using their public key, the sender public key. But it's not confidential. Everybody can get that message and can use the sender's public key and read it. Now, if you want to use both, if you want the message to be confidential and also authentic, then it needs to be encrypted twice by the sender. So it must be encrypted twice. Once encrypted by the sender's private key, so you can read it later on and be certain it's him, but then, or her, but then you have to encrypt that encrypted message, encrypt it again using the receiver's public key. And that makes sure then it's confidential. So if you need a message to be confidential and authentic, it has to be encrypted twice. And it has to be encrypted twice in the correct order. Encrypted by the private key of the receiver first, and then by the receiver's public key. So the private key of the sender, and then followed by the public key of the receiver. So here's what you need to do if you want to send a message that's both confidential and authentic. So if you're asked, how do you send a message in using public key encryption system that's authentic and confidential? We take the plain text message, that's A, from user A, and encrypt it using whose key? A's private key. PR here short for private, and A is this guy here, user A, or the sender. You can use S to indicate it's the sender. And that message, that encrypted message that we have, this message is encrypted again using the public key of the B user, user B, who is the receiver here. So we encrypt it first using the private key of the sender, then followed by the public key of the receiver, and send it out, and this is now the message. So this is the ciphered message. So this is the ciphered first cipher, and then ciphered again, C2. So the message is encrypted twice, and for the receiver to read it, they must also decrypt it twice, and decrypt it in reverse order. So this one, the second encryption happened using the public key of this guy, of B, the receiver. Now we use the private key of the receiver first to decrypt this message. And that will generate, so we use the private key of the receiver B to bring it back to the C1, the first encrypted message, which was encrypted by the sender's private key, and now we use the sender's public key, the public key of A, and that will bring back the message. So it's two encryptions. You need to physically know exactly and in the correct order. And the steps are written here so you can follow them from there. This was another